There's a big silence in our planetary backyard, and by silence I mean raging storms. Our view of the Southern Hemisphere is dominated by something we call the Southern Hemisphere Silence, which is that there are almost no storms down there. But is this really true, or is there more going on here? This is the space race. You might be wondering what I'm talking about when I say the Southern Hemisphere is silent. So let's take a look at Jupiter first. Here's an image of Jupiter from Juno, showing its iconic bands of clouds in amazing detail. You can see that most of the storms are in the northern hemisphere. There's hardly anything in the south. Here's another image from Juno. This one shows a lot of activity in the north, and almost nothing in the south, except for a couple of small storms over there. In fact, if we combine images from all of Juno's flybys, we find that around 86% of storms occur in the north. It's the same with Saturn. Here's an image from the Cassini spacecraft. Most storms again are in the north, and in this image, there's only one very small storm visible in the south. In fact, after analyzing every image Cassini took, scientists found that only 3% of storms were in the southern hemisphere. Neptune is next. Here's an image taken by Voyager 2. Again, most of the storms are up north, and this one is pretty famous because it shows a giant dark spot, which is basically a massive storm. Neptune's south pole is right here, but there's no major storms there. But wait, we have one more example. Let's go back to Earth. While studying hurricanes, scientists looked at over 100 years of data, and they found that on average, there are about twice as many tropical cyclones forming in the northwest Pacific each year as in the south. So why is the south so quiet? There must be some reason for this pattern, right? Well, yes, and it's actually quite simple. It's all about heat. Storms are powered by heat and hot air rises. So storms form where there's a lot of rising air, and there is a lot of rising air near the equator, because that's where the sun shines directly down and heats the surface. Hot air then rises from the surface into the colder upper atmosphere, and when it cools, it forms clouds, and also that forms storms. That's why the intertropical convergence zone exists, which is a band of thunderstorms near the equator. But as you move away from the equator towards the poles, there's less rising air, and thus less storms. And actually, the further you get away from the equator, the more the atmosphere gets deflected by the rotation of the planet, which causes air to flow in different directions depending on whether you're in the northern or southern hemisphere. That's why you get Hadley cells, Ferrel cells, and polar cells. Air rises in the tropics, travels north and south, then sinks, and then the whole thing starts over again. And that's why we have more storms in the northern hemisphere on Jupiter, Saturn, Neptune, and Earth. The problem is that this explanation doesn't explain why it's even more quiet in the south than in the north on these planets. After all, the sun shines on the equator on both sides, so why isn't it equally silent in both hemispheres? Well, to answer this question, we have to talk about Uranus, because this planet shows us that there is something else at play here. As you can see, Uranus is not a nice sphere, it's asymmetrical. The northern hemisphere is much larger than the southern hemisphere. Uranus is also tilted on its side, so the northern hemisphere receives more sunlight and stays warmer for longer. That's why the atmosphere on Uranus is more active in the north. And that's also why the northern hemisphere of Uranus is so much bigger than the southern hemisphere. Over billions of years, convection currents have transferred heat from the north to the equator, which made the atmosphere expand. This process is called advection. Now, you might think this shouldn't affect our view of the planet because as Uranus rotates, the same areas would be illuminated on both sides. But that's not true because during a Uranus year, which is 84 Earth years long, the axis of Uranus stays pointed in the same direction. That means the northern hemisphere always gets more sunlight and stays warmer. So the atmosphere on the northern hemisphere of Uranus never fully cools down. That keeps the atmospheric gases in the north from condensing and falling as rain, and therefore, the north can never get out of this state. Scientists think this is also why Uranus doesn't have rings. All its rings are opaque and rains continuously in the south. And since the south is always cold, all the water vapor in the atmosphere condenses and falls as rain. Eventually, the water reaches the core and turns it into a liquid ocean. But the north is so warm that the water can never cool down enough to condense, and thus it never rains in the north. Instead, all the water vapor just stays in the atmosphere. That's why Uranus is so asymmetrical and why it has no rings. But does that also explain why the other planets are so quiet in the south? Could it be that it's just our limited viewing angle? To find out, we have to look at a planet that rotates much faster. This planet is called Jupiter. It rotates once every 10 hours. If we watch Jupiter for just a few months, it looks like the southern hemisphere is just as stormy as the northern hemisphere. But if we simulate how Jupiter would look like if it didn't rotate, then we can see that the south is indeed much quieter. In fact, simulations show that around 90% of storms on Jupiter would be in the northern hemisphere. And when we look at the other planets, we can see the same thing. Almost all the storms on Saturn are in the north. Same goes for Neptune. Of course, you could argue that this is still our limited view of the planet. For example, we only see 270 degrees of Saturn, because it takes 27 years for the planet to rotate once. But while it's true that our view is limited, the asymmetry we observe on Uranus tells us that these planets are indeed more active in the north. We just don't know why yet. Some scientists think it has to do with the fact that the northern hemisphere of these planets is always slightly warmer than the southern hemisphere. But others say it's due to some complex interactions between the atmosphere and the magnetic field of the planet. We really don't know. The only thing we know is that the Southern Hemisphere Silence is real, but it's not as real as you thought. Now check out why Venus is hell on Earth's twin, or click this other video instead.